Hello, good afternoon. How does this move? Yeah. So Benjamin Franklin in 1784 was so excited when he discovered the bifocal glasses. It makes us realize that not only from centuries ago, but even more so now, addressing presbyopia is all but an inevitable need. The demographics of longevity are changing. People are living a lot more and different kinds of lives. And you can see that it's estimated that by 2020 in US, you'd have 20% of the population who are over the age of 65 and 50% of them having an operable significant cataract. And if we were to look at the new gen elderly, they're very different from the older elderly that we had. They perceive themselves as being younger, both in age and outlook. They do perceive themselves being a lot younger. They're confident. They're in control of their lives. They no longer want to hoard possessions, but they want to live a life of experience and adventure. Okay? Coupled with that is, there is no doubt that this is the era of smartphones and tabs, and they're ubiquitous and present everywhere. If you put both of these together, you find that research has shown that even as people approach 65 and beyond, more than 60% of them are friendly with the internet, and more than 70 to 75% of them go online every day. And that's what makes you wonder that what then is the most perfect IOL? I would think, therefore, we would tend to steer towards offering multifocality as an option for these patients. So the perfect, even if you were to look at a multifocal IOL, the most perfect lens would be one which allows the most natural way of seeing, providing as completely as possible a restoration of all visual function whilst minimizing the side effects. So presbyopia correcting IOLs that came into the market have revolutionized the way we look at cataract surgery today, because evolution of materials and designs allow us for balancing out of your functionality and reducing the side effects. And this is the range of all the IOLs that have come into the market over the last decade or more. The issue that comes with the bifocal IOLs, we know it gives you 2 point foci, one distance and one near. But the biggest drawback there is a significant lacuna in the perception of mid-range vision. Accommodating IOLs work while changing the dioptric power of the eye by changing their position, either by moving forward in the optic, but that requires the pliability of the lens capsule and again can be rather unpredictable. The edge-slit design of the extended depth of focus IOLs, true, they do give you some amount of a significant range of intermediate vision, but there is almost always a compromise in the near vision, as I have seen and most of us have seen as well. So that gets us to thinking that which is the lens that's probably the one that's going to give you the perfect balance between distance, intermediate, and near vision, and minimizing any of the problems. And the trifocal IOLs seem to be the answer to that. And the TrIDFF trifocal of IOCare seems to deliver what it says it'll promise. The way in which these trifocal IOLs are created, you've got two bifocal lenses which are superimposed one on top of the other, giving you 3 different foci. So now, not only do you have a focus for distance, you have a focus for near, which works like a 3.5 ad, and you have an intermediate focus. So you have the third point of focus, which works like a 1.8 ad. So this has got ridges, as you can see. Now what you need to know is the height of the ridge determines the amount of light that enters for near. The width of the ridge determines what is the near ad. So wider the width wider the width of the ridges, less is the near ad. Nearer they are, greater is the ad. So that's how it really works. Another subtle difference in its design is that there's a rounding off of the edges of the peak as well as of the trough. All of this results in reduction of the overall glare and the other photic phenomena. Dynamic energy transfer is another thing you need to understand. It's simple. It is actually streamlining the distribution of light depending on the ambient lighting conditions, and that's how the apodization on this lens surface really works. In apodization, you have the ridges, these ridges that go lower and lower as you move from the center to the periphery. So how does that work? Under normal lighting conditions, when the pupil is small, you have more amount of light that goes in for near, and as the pupil dilates in mesopic conditions, or when the pupil dilates, more amount of light, because the ridges are going down in size, more light is allowed for distance. So even the light near distribution is extremely well balanced out. Also, the spherical abrasions in this length correction is almost to 0, and you have almost minimalization in the reduction of the overall contrast sensitivity. So I will just, I'll come on to, where is my So this is a small video of the lens. So it comes in both designs. We use the plate haptic one. In terms of the biometry, it works very well. The A constant works as 118.28. This is the lens, as you can see. You have to orient it such that the leading haptic has a hole on the top left and the bottom right. And it's a nice thin lens that fits very easily and is injected equally easy. I should just show that to you. So that is just the lens. And under HPMC, with significant ease, it is loaded in place, flexed in, and once the injector once the cartridge is shut, it is injected with ease into the eye. It's brought out onto the surface, and extreme ease, it goes into the eye and sits in the capsular bag. Again, then, I mean, we obviously need to know that the surgery has to be pristine and well done. Look for the centration and the orientation of the first and third Purkinje images. They should be well aligned and in sync with the center. And at the end, it would appear like this. So I'd like to just share with you the results of a small study that we did where we looked at the lenses in great detail. So the way in which we actually had to you want to evaluate the visual performance of any lens, there are three things you need to look at. One is the visual acuity, where we looked at the uncorrected and the corrected distance, intermediate, and near visual acuity. Second is we looked at the contrast sensitivity, and finally we evaluated the range of vision by doing the defocus curves. The biometer, I would suggest that when we do use these premium lenses, you stick to any one biometer that works for you so that you can end up optimizing your A constant if required. We used an optical biometry, and to start with, we used two formulae, which is the SRKT and the Barrett, and we went with the closest to the minus, and we took the A constant as 118.28, which is what is suggested by the company. The visual acuity, which was checked in all our patients, and using this biometry, this is what we found. In our total 15 eyes that we got, we found that 25% of our patients ended up with a planar refraction, and about 53% had a tiny cylinder of about 0.5. So 80% of our patients were almost near normal, and only three out of those 15, that is 20%, had a small spherical residue of about not more than minus 0.5. And finally, then that's the one part of it. But then when you need to actually understand, is this lens or any lens actually performing in terms of giving you that intermediate range of vision, we did that using the defocus curve. Now, what you need to understand in the defocus curve is it is the objective way of evaluating the range of vision for intermediate, near, and distance, and the way you do it is by just evaluating the visual acuity at different distances. It works on the refractive principle that F is equal to 1 by D, which means where F is the focal length and D is the diopters of accommodation. So to see clearly at 1 meter, you need to use 1 diopter of accommodation. Similarly, if you were to plot a defocus curve for a pseudophakic eye, so for a patient to see clearly at 1 meter, the lens should have inherent in it 1 diopter of accommodation, and that's how it can be worked out. So to see clearly at 66 centimeters, accordingly, you need to, the lens should have inherent a 1.5 add. And it's plotted like this, wherein the horizontal axis shows you, and how you do it is keeping the distance correction in place. You keep adding minus lenses, so that's on the horizontal axis, and the vertical shows you the vision. Now, in a monofocal IOL, this is the kind of pattern you'll get, where you get a little bit of pseudo accommodation and a drop. In a bifocal IOL, you'll get that typical double hump, which you do get, but you have nothing working in your area for intermediate vision. And these are our graphs of our patients where we looked at when we did the trifocal IOLs. These were the graphs we got. So for example, if I were to look at graph number 13, if you see at 1.5, at 66 centimeters, the patient still has 6/9 vision. So we evaluated at at 66 centimeters, the kind of vision we got. And this is what we found, that 33% of our patients had a visual acuity of 6/9 or better. If we took 6/12 as a cutoff, which is standardized, considered as normal for even drivers, for driving in the world, we found that almost 75% of patients had fabulous vision in the intermediate range. And finally, we looked at the contrast sensitivity. What is important in looking at the contrast sensitivity is the Snellen acuity works on the principle of having a fixed contrast of 94%, which does not replicate what we have in our day-to-day living in normal different lighting conditions. So we use the Mars contrast sensitivity chart after stabilizing and standardizing the background illumination to 265. This is what, and then we needed to compare it with something. So the near normal, people in their 40s and 50s had a contrast of about 1.7 to 1.8. And this is what we found, that 66% of our patients had a log contrast sensitivity of more than 1.6. And if we took it between 1.5 and 1.59, about another 25% fit in that range. And it was even better than the commercially available other IOLs. The study for this is farther on. And finally, I've come to realize that at the end of the day, you want a patient who is happy. Whatever else you get are just numbers. And we found that patient satisfaction related to the fact of what he perceived his visual acuity to be, whether all his needs were met or not, whether he was having any photopic phenomena, and what was his vision in night, in dim lighting conditions. And subjective perception at the end of the day still depends on his personality, his need for extreme close work, and what is his environmental illumination. And finally, so in our study, we found only 2 patients who were not so happy. None of them, because in the evening time they needed brighter light, which I find with all class of multifocal IOLs, they have to understand that they are going to need much brighter light for near work. None of the patients had any photic phenomena. And finally, you have to understand that if the lens doesn't work for you, or if the patient is unhappy, you have to rule out other causes of dissatisfaction, which is, it could be even a spherical ametropia. A small cylinder can cause significant amount of glare and halos. Any residual astigmatism or a spherical residue. Does the patient have something like a dysfunctional tear syndrome, because that again causes aberrations and halos, whether he's got a Yagerbil posterior capsule or a cystoid macular edema. In conclusion, I would like to say that if you've been absolutely sure about your biometry, if you've ruled out any other causes of ocular comorbidity, if you've understood that which of the visual needs of the patient you need to address, if your surgery has been precise, then I can assure you that the TrIDFF trifocal would deliver, and how. Thank you very much. And this is an interview of the patient.